Now let us look at the next problem. In the given circuit, the AC source has omega as 100 radians per second. Considering the inductor and capacitor to be ideal, the correct option is R. Okay, so you have an AC supply of 20 volts, 0.5 Henry inductor, 50 ohm resistor connected in series. Now this combination is connected in parallel with a series combination of 100 microfarad capacitor with 100 ohm resistor. We have to find out which of the following statements are correct. Okay, now let us see the first upper loop. This loop let us study. Now this is a RC circuit, okay, connected to a alternating voltage. Now if you assume that the voltage applied is having a phase in this direction, then voltage in the resistor will be leading the voltage in the capacitor. This we already know, and the resultant of VR and VC will be in this direction, VRC, which is the applied 20 volt voltage. If we make the impedance diagram or triangle for it, the resistance R1, that is 100 ohm, and capacitive reactance XC, they will be also making this angle, and let us say phi 1 is the phase angle. The value of XC is given by 1 upon omega C. Omega is 100, C is 100 into 10 to the power 6, that will make it 10 to the power 6 up. So the answer is 100 ohms. So here you have 100 ohms as XC and 100 ohm as R. So the value of phi 1 is 45 degree. Okay, because tan phi is given by R upon XC. Sorry, XC upon R. Okay, I'm sorry, this is XC upon R, which is 100 by 100 equal to 1. Therefore the value of phi 1 is 45 degree. Okay, now let us look at the lower arm of the circuit. Inductor and resistor is there. This is actually 50 ohms. Now we know that the voltage in the inductor leads the voltage in the resistor in case of LR circuit. Okay, and the resultant of these two will be in this direction because it is the same voltage that is applied here. So the total voltage across LR and total voltage across capacitor has to be same because they both of them, they are connected in parallel. Okay, and in turn connected with 20 volt AC supply. So this is 20 volt AC supply. Same phase impedance triangle will be made in this case, where R2 will be here and XL will be here. Now what is XL? XL is omega L, which is 100 into 0.5, that is 50 ohm. Now again this is 50 ohm and resistance is also 50 ohm. That means this angle, phase angle, has to be again 45 degree. Okay, now keeping this thing in mind, the current in the first circuit will be along the R1 and current in the second circuit will be along R2. Okay, and the resultant of these two will be somewhere here. Now phi 1 and phi 2 both are 45, so this is 90 degree. So the value of I can be written as under root of I1 plus under root of I2. Now first of all let us find out the value of I1. Value of I1, that is RC circuit, will be given by voltage applied upon impedance Z of the RC circuit. Now voltage applied is 20 and impedance will be given by XC square plus R square. Okay, now this is 20 divided by under root of 100 square plus 100 square, which is 20 upon 100 times root 2, which is equal to 1 upon 5 root 2. Okay, similarly in the LR circuit, the value of I2 will be given by applied voltage V upon impedance Z LR, okay, which is 20 under root of XL square plus R square, which is 20 upon under root of 50 square plus 50 square, which is 20 upon 50 root 2, which in turn will give the value of 2 by 5 root 2. Okay, now this value of current I, that is flowing from the AC source, will be given by under root of 1 by 5 root 2 plus 2 upon 5 root 2, both squared and then added. Okay, now 1 by 5 root 2 will come as a constant, which will come out of the under root expression, and we have 1 plus 4 under root, which is equal to root 5 upon 5 root 2, which can be written as 1 upon root 10 or root 10 upon 10. The value of root 10 is roughly equal to 3 point something divided by 10. We will have 0.31 ampere as the current flowing from the AC source. Okay, so the current flowing in the circuit is 0.31 ampere. Okay, so this option is correct. Current through the circuit is 0.3. This is incorrect. The voltage across 100 ohm resistor is, okay, now in the 100 ohm resistor, that means in the RC circuit, the value of current was 1 upon 5 root 2. If you multiply it with the resistance, that is 100, we will get 20 by root 2, that is 10 root 2. So this option C is also correct. Now the voltage across 50 ohm resistor is 10 volt. Now let us see this. Current I2 is 2 upon 5 root 2. If you multiply it with the resistor, that is 50, we will get the voltage across this. Okay, now this is 20 by root 2, which is again 10 root 2. So this option is incorrect. Option A, option C are the correct one.